Okay, this lesson is on rational expressions. The first thing we want to do is really talk about what a rational expression is. First of all, the word expression means there's no equal sign. It's just an expression like 1/2 or 3/4 or x plus 2. Rational means it's anything that can be written as a fraction. So a rational expression is a fraction in which the numerator and or denominator are polynomials. So let's kind of break that down. First of all, we know what a fraction is. We know the numerator is the top, the denominator is the bottom. Now, polynomials. Remember, polynomials is kind of a generic term that talks about monomials, binomials, trinomials, and polynomials. And remember how we know between, so we could add polynomials in there. A polynomial could be 3x to the 4th plus 2x squared plus 7x minus 4. So poly means many, and in this case it would be more than 3. We have special names for monomial, binomial, trinomial. Remember, it's just how many chunks or how many terms we have. So this has one term. This would be another example. X plus 2 has two terms being added or subtracted. 3x squared plus 4 would be a binomial. A trinomial has 3 terms. A polynomial has many terms, and a polynomial is used to talk about all of these. We just have special names for monomial, binomial, and trinomial. Examples of a rational expression would just be, well, it's a fraction, 3 over x plus 2, 3 over a binomial, or a binomial over a binomial, or a monomial over a monomial. So as long as you have one of these, it would work as a rational expression. So we have a couple goals for this lesson. Our first goal is to, actually 1 and 2 are kind of going to go together. It's to simplify rational expressions. That would be your first objective. And your second objective is to multiply and divide rational expressions. Now, the simplifying is part of the multiplying and dividing rational. Oops, I lost the word rational, didn't I? Rational expressions. So today for your lesson, we have this particular worksheet, and we have some reminders here. Did you factor completely? When in doubt, factor it out. We used to say graph it out, but in this case, when in doubt, factor it out. Can you cancel anything? Did you find all the values where the expression is undefined? Remember, denominator cannot equal 0. So this is part of the domain. And did you write your final answer as an expression? Now, we have a warning. I love Big Bang and Sheldon. His warning is every time you do this, a kitten dies. I don't know if you've watched the show. That's something that he says. Not really, but yes, he does say it. So the big thing that we want to be cautious of is when we are simplifying, we cannot just cancel an x squared for an x squared. So I'm going to scoot it down here a little bit. If I have x squared plus 2x plus 1, that's a trinomial. That's one package deal. If I have an x squared plus 3, I cannot cancel, or let's say they had it as an x to the 4th. I can't cancel these x squareds because of this plus or minus. So this is a package deal. Anytime you see the plus or minus, that is a package deal. You cannot break it apart. The only way you can break it apart is by factoring it and writing it as a multiplication problem. So that's something that we need to keep in mind. We're going to start with example number 1 here. We have 12y squared x, 4y, and we're multiplying. Remember, we can cross cancel. And remember our exponent rules. If we, and if we can't cross cancel or cancel a numerator and a denominator, then we're just going to simply multiply straight across. So sometimes, we talk about getting our negative exponents, simplifying those out. You could do that way. So I have 12y squared x over 4y. Well, everything went to the bottom, so it'd be 1 over 3y squared. Or you could add your exponents. That's up to you. So now we can cancel. Got a y squared and a y squared. I have a 3 goes into 12 4 times. 4 goes into 4 once. 4 goes into 4 once. So I'm left with x over y. Now, what makes my denominator 0? Well, y cannot equal 0. That would be my, where it is undefined. So that would be my answer. Experiment number 3, parentheses say we multiply the fractions first and then add. So I'll leave that one to you, and then you have an experiment 2. Now let's look at experiment number 5. So I'm going to do this one on a piece of paper so I have a little bit more room. So experiment number 5. We have x cubed minus 8 times 1 over x minus 2. So the first thing I need to do is I need to factor. Because I have a binomial and I have a binomial, I need to factor these. We'll write it as a fraction. Remember, when we have an x cubed minus 8, we need to think about that. Well, that's 2 times 2 times 2. The sign follows, so when we're factoring, this is a blast from polynomials past. So we'd have x minus 2. Remember, you're only allowed one minus sign. We square the first. We've already used our minus sign, so it's a plus. We multiply them together to get our middle, and then we square our last. Over 1. And then I'm multiplying that by 1 over x minus 2. Now I have two things being multiplied together. Since I have two objects being multiplied together, now I can cancel. So I'm going to cancel my x minus 2 and my x minus 2. And I get an x squared plus 2x plus 4 over 1. Now, what made my denominator equal to 0 originally? It was when x equals 2. Because x minus 1 equals 0, so x equals 2. So we know x cannot equal 2 because in the original form of this problem, that was considered undefined, even though it canceled. If we think about a graph for this, the graph would be around 2. The graph would just have a little hole in it and keep going however it would go. So we're not going to hit graphing at this point, but that's what's happening here. This canceled. I know it canceled, but originally it was in the denominator, so that is a undefined point of the graph. All right, so let's look at another example here. Let's look at example number 7. I'm going to write that on another piece of paper as well, so we have a little bit more room. So I have x squared minus 5x plus 4 divided by x squared plus 1. And I'm multiplying that by 4x cubed plus 4x over x minus 5. All right. So I have a trinomial and several binomials, so I need to factor it. I can factor this guy by saying 4 and 1. So x minus 4, x minus 1. And then I get an x squared plus 1. And I'm going to multiply this by, I'm going to pull out a 4x. There's going to be a lot of that. You need to GCF it. So 4x times x squared, 4x times 1. And then I have an x minus 5. So now we can cancel. This is a package deal. I have an x squared plus 1 and an x squared plus 1. Nothing here is going to cancel out. So I have an x minus 4, an x minus 1, and an x minus 5. Now, this is going to give me an irrational, or this is going to give me a complex number. If I were to set that equal to 0 and solve. And remember, sum of squares I cannot factor. So I have an x squared is -1, and when I square root, I get an I. So that doesn't give me an undefined value, but this does. So x minus 5 cannot equal 0. So x cannot equal 5. That's in the denominator. Now, some of your answers, they'll go ahead and multiply that back out. But for this example, I'm not going to. So that was experiment number 7. Let's do one more experiment. Let's do this one. If I have 7r squared plus 51r minus 40 all over r squared minus r minus 72. So this is, I'm just going to do this as example 3. This will show you some division as well. And I'm going to divide that by 49r squared minus 21r minus 10 over 7r plus 2. This is called a complex fraction. Meaning I have a fraction divided by a fraction. So let's write it horizontally so we recognize what it looks like. This is kind of a beastly looking thing, but let's start there. So really this problem is saying this fraction so this is fraction number 1. This is fraction number 2. So that's saying this fraction divided by, so fraction 1 divided by fraction 2. So that looks a little bit better. It doesn't look nearly as gnarly as that one did. So the next thing that we're going to do is we're going to remember when we divide fractions, we keep, change, flip. So we're going to keep this one the same. Seven r squared plus 51r minus 40 divided by r squared minus r minus 72. And now I'm going to multiply by the reciprocal. So I'm going to flip this. I don't change any signs. I just flip it upside down. All right. So now, when in doubt, factor it out. So we need to factor these guys. I'm seeing a 7r plus 2 here, which tells me probably, the way these problems are written, I'm going to have a 7r plus 2 in one of these. I would bet that it's going to happen here. So let's think about this. If I have a 7r, then I need another 7r. 7r times 7r is 49r squared. If I have a 2, I'm probably going to need a 5, because 2 times -5 is -10. So let's check the middle. So I'd have -35 plus 14. -35 plus 14 gives me -21. So that's right. All right, this guy, 72, I've got 8 and 9. I need a negative r, so I know I need an r minus 9 and an r plus 8. Most likely, the way these problems are written, one of these is going to be a factor up here. So I would say that probably it's this r plus 8. So let's see if that can help me. If I have an r, then that needs to be a 7r. So 7r squared. And if I have an 8, I need a negative 40, so it's probably a minus 5. So let's see. 56 minus 5 is 51. Beautiful. So we have rewritten these as those. So now we can start canceling because I have a product. So 7r minus 5, 7r minus 5. Oh, look at that. That's pretty. 7r plus 2, 7r plus 2. And I have an r plus 8 and an r plus 8. So it looks like everything canceled in the numerator. So I have 1 over, and then I have an r minus 9. Now, that was quite pretty, and a lot of these will come out very pretty. So, just the way the problems are written. The next thing we need to do is find out what r cannot equal. Well, we know r cannot equal 9. We also know that r cannot equal 7r plus 2 cannot equal 0. So if I solve, r cannot equal negative 2/7. And if I set this equal to 0, 7r minus 5 cannot equal 0. I'm going to get 5/7. And don't forget this guy, he canceled. It cannot equal negative 8. So it can equal a lot of values, but it definitely cannot equal these.